I'm going to show you in this short video, 5, 6, 10 minutes, how a window motor works. We're going to strip it and we're going to scope it. This one's knackered, it's got 2 knackered hall sensors, so sadly I won't be able to show you in live real time how good the hall sensor signal will be if it was a good motor. But what I will do is I'm going to strip it down, commutator, stator, everything like that. You'll see all the components, working components, how I reassemble it. But more importantly, by the end of this video, you'll know how a motor works, a window motor works, how it detects anti-pinch and stuff like that. So stay tuned, you're going to love this video. Not done one on TikTok for a while, so I'm looking forward to doing this for you guys and gals. Right, Thomas, we've got a motor, but I don't know what it's off. I think it's off a Mini, but the only issue is, unfortunately, it doesn't match up on the wiring diagram. So what I'm going to do is I'm going to work out these motor lives, positive and negative, where they go in relation to these pins here. Well, I already know they go to these 2 massive ones here when the motor goes inside like that. I need to now work out on the circuit board exactly where they're going to go. So the easiest thing to do is do a continuity test. Just jab it on there like that and see which pin it matches up to. Oh. So it's that one of these pins, which looks like pin number 1, and the second one is that one. So it's pin number 1 and pin number 5. I never would have known that. And then the rest is the hall sensor ground, and 2 more is the hall sensor signals. We need to now work out which is the ground and which is the signal wise, but we have to strip it more to do that. Right, Thomas, so I'm trying to go on the signal wire here now to make sure I know which is the ground, which is the signal. So it only has continuity to 1 pin on 1 hall sensor, so that's probably the signal output. So we'll go on to the other pin now. We should have no continuity. Good. But we do on that one and none on the other. So I'd say that's the signal there, and then that one is that signal. Very, very dry solder. I changed this for a reason. So what is the motor layout? Well, this is the motor layout. So let's start from, where do you want to start from? Well, first of all, we've got the casing. That's the stator. It's got the 2 semicircular permanent magnets in there. The rotor. Then you've got the armature, which is wrapped around many times. The more armature you have, the more efficient the motor is, the more torquey. And you notice the commutator, that's the bit what the carbon brushes go against. You notice they've got these slots here, and those slots are obviously to separate the north and south poles of the magnet so that the thing can keep actually turning. Then you've got this encoder ring, and that's the bit which the hall sensors sit around. There's a slight air gap, I'll show you that in a minute. And obviously that is responsible for the digital signal output, so it knows exactly where this is in relation to the window. And we have the circuit board. 2 hall sensors. On this one they're actually damaged, and you'll see that in the scope trace, which I'm going to show you. The 2 massive fingers you can see there sticking up, 2 prongs, that's the positive and negative parts for the motor. 2 signals, also a power supply and a ground. So the job of this motor, that's its support bearing at that end there. There's a ball, I think it's a ball bearing set up in there. But the job of this motor is to convert this longitudinal motion 90 degrees via some gears in there to then send your window up and down. So essentially that's it in a nutshell. That is the motor in a nutshell. There's a lot better explanations online. One video on YouTube with 20 million views, it's fantastic. And you can find out more about things like the commutator. So inside here we have the hall sensors, as we've already kind of we understand. There's your hall sensors there, wax coated. The motor is going to mesh into here because that's the power supply for the motor, for the forward and back movement, these 2 pins here. And this is our encoder ring, so obviously as the window's going up and down, it's turning like this. And it's changing, it's making these signals move. So obviously if someone's going to stick their hand in a window, the anti-pinch, it's going to slow right down like that. And as it slows down then stops, it's because these signals are stretching, because it's basically slowing right down in the position of the hall sensors. You can just see the hall sensors there. They'll have an air gap, something probably kind of a bit like that, maybe a fraction of a millimetre. You see there's a slight air gap. If it's touching, it won't work, because these also work on that kind of principle of inside this encoder, it'll be actually made in a certain way that it will create this signal. It's quite a clever system, really. So that little wheel there is extremely important, essentially. And it's a bit like how an ABS sensor works. There's not really any difference, to be honest with you. It's just a way of digitally switching something on and off many times. So let's assemble this and let's crack on. Right, so now we're going to build this back up. I'm going to slide the circuit board in. Home. It all just snaps together nice. Oh, very loud snap. So now your circuit board is fixed. And we're going to get this. And obviously we're going to have to put this in here where it belongs. Mesh that in nice. We've got to get that in the gears now. One thing I didn't mention actually is the worm gear. So this is just a 90-degree worm gear, which then obviously inside here there's another gear wheel. So we turn this type of rotation 90 degrees, like a differential in that sense, to 360-degree rotation to 90-degree rotation, obviously to do the work of the window motor. So when you're actually assembling these, you need to pull this support bearing inside like that. And then that allows it to run a bit smoother, and it should go straight in with a bit of luck. Of course, it never works like that when you're filming, but in this case it did work like that. So that's now in. So all we need to do is put the stator on. That's the magnet bit. You can see the two circular magnets and the semicircular magnets. That's good. And you can see, look at that, look at the magnetic action of that. It's fantastic. It's very hard to pull it apart because it's magnetic. And in the end you've got the bearing which it spins on. So you've got a pilot bushing at the front, sort of here. You can just see that's the shape of it. Then you've got a centre support and you've got the external bearing here in the stator housing. So we've got our QDB set up here, essentially. And what we're going to do with this is we're going to just put a variable voltage output on it. I'll have to reset it. So I've got this wired up that I can vary the motor. You can just see the motor moving there. And essentially that's the issue. The Hall sensors are just completely shot at. They're literally doing nothing. And that's the reason why I changed this motor, because the Hall sensors had failed on it. And we're giving this really weird pattern. And this is also very good if you want to scope something. You can actually see with the scope as we adjust it. You can actually put it on full voltage output, full chat. .8 volts there. This one is 70% okay, so the red trace is good, the blue trace is not good. This is off another motor from 2 or 3 years ago. But the point I'm trying to make is I'm trying to show you that that's what it should look like. You should have a nice square pattern. Of course the blue one's a bit distorted. And this was actually visible water on the circuit board. So that's, if you can imagine that the blue one should look like the red one, then you're in business and you know what it should look like. I hope you learned something from that video. I certainly enjoyed making it.